Have you ever wondered, are we alone in the universe? To find out the answer, I'll interview Dr. Tomasz Zajkowski, an astrobiologist from NASA. Hello, Dr. Tomasz. How are you?
I'm doing great. How are you, Carolina?
Good, thank you. I know you work in NASA as an astrobiologist, and I'll ask you a few questions about space and the universe. Okay,
Amazing.
now I'll
Yes.
ask you some questions. I know you're an astrobiologist. Can you tell us what an astrobiologist does at NASA?
Absolutely. So starting from the beginning, the astrobiology is the study of life in the universe in the broadest context that you can imagine. We are interested in fundamental questions such as where did the life came from? How did it evolve? Where we can find it? And are we alone in the universe? So at NASA and in general, astrobiology is divided into different research areas or subjects. And some of us study, for example, exoplanets, trying to figure if on the other planets there are conditions that life could emerge and evolve. There are people that work on life detection missions, so they actually build instruments that fly to other places in our solar system, but they also try to invent missions that would fly to different stars to search for life out there in the future. Uh, there is also a lot of people that work in the laboratory and on research, trying to understand what is life, what is the common characteristic of life, what is the limit for life, where does it make sense to look for life if the conditions are not too harsh for even microorganisms or not. Then another field would be astrobiology in the sense of organic chemistry, of astrochemistry. So, what are the ingredients for life and where are they available? For example, we recently found out that there is quite a lot of organic matter, so things that life is built of. The building blocks are present on meteorites and they fall on Earth, delivering what life needs to evolve. And another, because as you see, there is a lot, because there's a lot of interdisciplinary collaborations of geologists, chemists, planetary scientists, and they all try to understand life in the broadest possible context. And that would be generally what astrobiologists do, including those at NASA.
Um, this would be a question that we are all interested to know the, for the answer. Do you think life exists on another planet, and can you explain how you search for life in space?
Well, I certainly hope that there exist. I would very much like to see and explore and understand the life on the other planet if we can find it. And the question that you asked about how do we search for life depends very much on what kind of life are we looking for. Are we looking for microbial life, just microbes, bacteria, something single cellular, something like bacteria? Or are we looking for technologically advanced, intelligent species which would leave a different mark in the space? So for microbes, to search for them, you can either look for disequilibrium in an environment, which means that we would look for signs of microbial activity on the planetary scale. On our planet, on Earth, for example, oxygen is all built up by biology. We would not have that much oxygen in our planet, in our planet's atmosphere. And it's so much oxygen that it is detectable with telescopes from many light years away. So someone looking on Earth could determine there might be life on our planet because there is so much oxygen, and at the same time, there's quite a lot of methane. And the methane is actually the biosignature in this regard. Uh, on the other hand, if we're looking for technologically advanced civilizations, these tend to be even louder than microbes. By loud, I mean we generate a lot of noise in electromagnetic spectrum, which could be radio waves, for example, that escape Earth and they can be detected. So something like a television signal can be captured and from outside, and someone could actually watch a TV, whatever we broadcasting uh, on a TV could be intercepted by aliens and they could watch our own TV. One of the first signals that have been sent was in about 1940s. There were first signals sent to space. So since 1945 or somewhere around that, the human presence has been announced and like with the loud signal. And because those signals travel with the speed of light, we are now detectable from the distance of what about 70 light years away. So as you see, this I think that's a good example that you can either look for artificial signals of intelligence or chemical signatures of microbes, or you can fly to another planet and try to capture the microbe and preferentially, we would like them to be brought back. So the sample return mission from Mars is going to be crucial in our search for life in solar system.
What is the most interesting thing that you have discovered?
Oh, that's an interesting question. Well, I'm very proud of my discovery of prions in archaea, and that's a lot of terminology. Um, so yeah, that's a conundrum of any specialized science that it is pretty hard to communicate it in simple words if you want to be concise and speak in short sentences. You have to use those terms that we study and we try to understand. So, but in general, it means that some organisms can inherit information like we share in genes from one generation to another. And we all recognize inheritance is based on DNA. I've been looking for different modes of inheritance that is outside of genes, and I have found one of them to be more ancient than we thought. So this is definitely something I'm proud of. And the implication of that research as well uh, is because the structures that I studied that are capable of this behavior of transmitting genetic information across species, across distances, generations without DNA, they're also very, very stable, which means they could potentially be used as biosignatures, footprints, and indicators that life existed here and those particles can be detected. So that would be like a sign of life that we can search for and no one yet is looking for. And I'm working on it currently to validate this idea to see is it feasible to look for these so-called amyloids as biosignatures.
How many other planets do you think are in the Goldilocks zone in our galaxy?
Oh, yes. So Goldilocks zone is probably my favorite theory. I very much like the cartoon version of Goldilocks zone, and that something is, oh, too hot or oh, too cold, but something can be right in the middle, right as we want it. And as well, the planets can be either too close to a star, and then the water on it will just boil, evaporate, and disappear, or they can be too far from the sun and everything freezes up. It's like locked in ice, and there is not much interesting chemistry going on, including life, which is a very complex organic chemistry, is what we think life is. So taking under account that in the Milky Way, our galaxy, there is about like 100 billion stars, there's probably could be even as many as 20 billion potential habitable planets. So quite a lot. And I just want to add one more thing to this, because in recent years, we have expanded the search of life for life in the solar system outside of our own Goldilocks zone within solar system. We are searching for a life on something called icy moons or ocean worlds, which are moons of the biggest planets in the solar system, Jupiter and Saturn. Uh, and respectively, that would be the moon Europa and moon Enceladus. They're far, far away out of the Goldilocks zone, but the liquid water seems to exist there anyway. And this is due to a different process than just capturing the energy from our star. They're too far to benefit from the energy and warmth of our sun, but they are in a interesting orbits relative to other moons. They in synchronous orbits, so they synchronized in their rotations. They always miss each other in a very specific way, and that puts their orbits into more elliptical shapes. So they're not going just around Jupiter, for example, or just around Saturn. Their slightly elongated orbits means that they're sometimes closer to the Jupiter or farther away. And that stretches the crust. It changes their shape. So while flying by, the shape is different and they fly away. So the crust of the moon is working and it gets hot. It gets hot enough that it has geothermic activity. So the inner core of the moon is liquid and hot rocks that emits this heat into a frozen uh, at the beginning frozen ocean, which melts, and now you have a moon which is covered with ice, a liquid ocean underneath, and then rocks and volcanoes, underwater volcanoes like we have on Earth, which are called hydrothermal vents. So these are other very alien words where we look for life, and they even expand the Goldilocks zone. So 20 billion possible words in Goldilocks zone, and probably even more and more outside of that. It really makes you think the life must exist somewhere, right?
Do you think humans will ever live on another planet?
Oh, actually, I think we have to. Yeah, I don't want to scare anyone, but we've been on this planet for quite a while, especially if we think about ourselves as anything living, including bacteria from which we evolved. So our planet is about like 4 billion years old. The life appeared on it very quickly, and well, our sun is changing. These are such a long time spans, such a long time that star, our sun evolves. And what we know about our sun is that it's getting brighter and hotter. And within the next billion years, so just 1/4 of all Earth existence, it's going to be so hot that Earth no longer going to be in a Goldilocks zone. So as the sun gets brighter and hotter, the Goldilocks zone moves out away from the sun, and Earth is not going to change its orbit. It's going to stay where it is in relative distance to the sun. So it's going to become too hot. And if humanity wants to survive more than 1 billion years, well, we have to leave and find another planet to leave. And Mars, of course, is the closest one that we could try to inhabit.
The last question is a very hard one for you. Do you believe in aliens?
Oh, I'm sorry, I'm an atheist. I don't believe in anything. But I'm very curious to find out if there are. Yeah. So it's all a matter of statistics, numbers, measures. And I'm trying to keep open-minded for any possibility. But also, I think the role of the scientist, if you want to describe who the scientist is a person who tries to prove themselves wrong as quickly as possible. So it's working hard to disprove ourselves, right? So there is very little belief in what we do. Even if we believe in something, we work hard to make it uh, to to uh, to prove it's wrong.
It was a pleasure talking with you. Thank you. I hope that our conversation will inspire even more of my classmates to discover galaxies. Bye.
Thank you.